Exam question revision video for GCSE indices. So let's have a look at the question. We've got 9 to the power of 3 over 2 and we need the answer, and 10,000 to the power of minus a quarter. So what are we thinking? Well, both of the questions are about powers or indices, which are also called exponents. We have fractions in the exponents, 3 over 2 and 1 over 4. And we have a negative in one of the exponents. So let's have a look at the first one. What do we think about this? Well, we have a 3 for the numerator or the top of the exponent fraction, and this means cubing. We have a 2 for the denominator or bottom of the fraction, and this means square rooting. And we can do these in either order. It's probably easier to do the square root first. So 9 to the power of 3 over 2 is the same as the square root of 9 to the power of 3. The square root of 9 is 3. 3 cubed is 27. And so we circle 27. If we'd done it the other way round, we would have had 9 to the power of 3 over 2 is the square root of 9 cubed. And 9 cubed is 729. And not many of us will know that the square root of 729 is 27. Unless we've watched this video, of course. So the blue version, the first version, is probably better. Okay, moving on to part B, we've got 10,000 to the power of minus a quarter. What are we thinking about this? Well, we've got a negative sign in the exponent, and this means finding the reciprocal, or putting 1 over whatever the other part comes to. We have 4 for the denominator, the bottom of the fraction, and that means finding the fourth root. And in other words, we need a number that gives us 10,000 when we multiply 4 of it, the number, together. Okay, and again we can do these in either order. So 10,000 to the power of minus a quarter. We'll first of all separate them off, so we can say 10,000 to the quarter to the power of minus 1. 10,000 to the power of a quarter, well, 4 tens multiplied together will give us 10,000. So it must be 10. The other thing is, they couldn't expect you, or me for that matter, to know what the fourth root of any old number is. It has to be a relatively straightforward answer, and so we know that multiplying tens together gives us 1 with however many noughts afterwards. So 10 times 10 times 10 times 10 will be 1 with 4 noughts. So 10 is what we need. Then we have to do that to the power of minus 1, which, as I said earlier, means finding the reciprocal, so 1 over 10. And so we can circle that. Now we could have done it the other way round. We could say 10,000 to the power of minus a quarter is 1 over 10,000 to the quarter, and then we go straight for 1 over 10, which is possibly easier. Doesn't really matter which way you do it in this case. Okay, got a bit of bonus material, and in the green lozenge there we have some of the rules of indices, and we can use them to look at things like, why does z to the power of minus n equal 1 over z to the n? So why does the minus sign give us the reciprocal? And there's lots of ways to look at this, but one way is, if we multiply z to the minus n by z to the n, even if we don't know what z to the minus n means at this point, we can use the rules of indices. So we use rule 1, and when we multiply the same number to different powers, we can, or the same power for that matter, we add the powers. That's the point. So that would give us z to the minus n plus n, and of course minus n plus n is 0, so that gives us z to the 0, and then by rule 4, anything to the power of 0 is 1, so that gives us 1. Now if we take the beginning and the end of that, we have that z to the minus n times z to the n is 1, so we can divide both of those by z to the n, and that gives us z to the minus n, because in the left hand expression, if we divide by z to the n, the z to the n's will cancel, and for the right hand one we just get 1 over z to the n. So that's a way of showing that. And the other thing we've been dealing with is the fact that the bottom of a fraction in the exponent gives us the root. So why is that? Well, again, there are lots of ways to show this, but one way is, if we take y to the 1 over m and raise it to the power of m, then we can again use one of the rules in the lozenge, in this case rule 3. So something to the power, you multiply the powers. So that means we have y to the power of 1, because m times 1 over m is of course 1. And y to the power of 1 is just y. Now, if we then take the beginning of that, the y to the 1 over m to the m, and do the mth root of it, then that means we've got the mth root of y to the 1 over m to the m, and the mth root of something to the power of m is the something, because they cancel out. We've got a power and a root, so they cancel out. So that equals y to the power of 1 over m. Now, we got that by doing the mth root of the first expression in the top line, but that first expression, y to the 1 over m to the m, we've seen is equal to y. So if we take the mth root of y, then that will be the same as the other expressions on the bottom line. And sure enough, that means we have the mth root of y, and so we've shown that y to the 1 over m is equal to the mth root of y. And then, just as a final little thing, we can collect up these various things we've been dealing with and summarise. So anything to the power of a over b, we can either call it the bth root of x in this case to the power of a, or we can call it the bth root of x to the power of a. If we have x to the minus n, then that's the same as 1 over x to the n. And if we put those together and look at x to the minus a over b, we get 1 over the bth root of x all to the power of a, or we could do 1 over the bth root of x to the power of a. And if that all sounds very abstract, don't worry about it too much. If you carry on studying maths, you'll get used to all this stuff.